Today, what are we going to study? I'm going to explain about the definition. The definition, how important it is. Now today you're going to realize how important it is. If you know the definition, the math will be solvable. If you know the math, then you will be the definition will be seen. Since as we study, the very first part is always the definition. But if you know if you cannot make out the definition, you don't even know how these questions were made up and how come these questions are made up. You don't even understand that. If you don't understand the math, but you just memorize with the memorizations, you will never know the fun of math, and the math will be very meaningless to you. Since you have the definition, after make out the definitions, you will know the properties of it. You have to study the properties. Out of the properties, you can induce the formulas. Induce the properties and then prove the formulas. Today we'll study about that. Okay, hold your pen tight, and then each one you write on your notebook. Okay, focus on the board. Let's define the log. During the high school junior and senior year courses, you will see often, and then this will be given in entrance exams. You have to make sure the definition of log. Each one by one, you have to write on the notebook, on the scratchbook. Did you write on your notebook? So what is the definition of log? Yes, when a is greater than 0 and when a is not equal to 1, the reference positive integer for reference integer b, positive integer b. So you already know the main bodies, A and B. Yes, it's right. And then the reference positive integer b. After that, a to x power equals b. The real number that satisfies this equation, the real number which satisfies a to x power equals b. Since the main body is a and b, this is about the a and b, the equation. It is only one. Only one. There is only one real number that satisfies this equation. Since it is only one, the real number, why do we apply this real number? Because it is log is one of the equation. This is equation, but induce or applied logarithm. What is the definition of the logarithm then? Even the logarithm applied to real numbers, even this equation we have to mention within the range of real numbers. Why is there only one? You have to be very curious about that and then make out the meaning of this definition. Out of this a to the x power equals b, what is it? It is the equational form. It's exponential form. we have to induce to logarithm. You have to think about that. A to x power equals b. What do we do? Let's say, in here, y is omitted that I have already taught you. You have to bring it in your mind. You have to draw a picture in your mind. What can we say again? Let's say y equals a to x power, y equals b. These two equations you can make. And even y equals a to x power, this exponential function, how many pictures, how many graphs can you make? Yes, two kinds. Right, this is x-axis and y-axis. Since you are junior and senior in high school students, you may know definitely. Okay, out of this table, did you draw the graph? Yes. Okay, this way. This is monotonous increase. So another one is monotonous decrease. Since a is greater than 0, it is monotonous increase. What is monotonous increase then? You have to answer me. You have to speak it out. After that, you hear your voice. That is you're given your confidence. Gain a confidence. Just like that, you have to study that way. Since y is b, what is b? Reference positive integer. For all the reference in positive integer, let's draw lines. Let's see. Do we meet at one point? Yes, it is. Aha. There is only one real number. How about here? In monotonous decrease, do we meet only at one point? Yes. This point, at one point, which meets is the solution of log or the solution of exponential function. We defined that's why we defined it that way. We have anticipated the one we were given next. Okay, since this is monotonically increasing function, since x is increasing gradually, y is increasing too. And if the monotonically decreasing function is since the x is increasing, y is when x is decreasing, y is decreasing too. You have to put it into your mind. Okay. Now already we have known that there is only one real number. The log is from the exponential function. Why did we study that? Since the number, when you meet the astronomical figures or the digits, we cannot express. So we apply the logarithm. Who made it? The Napier. He made the log. Okay, let's make out. We already defined the log, and then let's move on to the next. The properties of logarithm. Okay, we have to study the properties. Beforehand, we move on to the properties. We have to study the relation between the exponent and the logarithm. A to x power equals to b. If we change it into logarithm form, it is log base a to b. So what is a? It is base, and the b is anti-logarithm. Anti-logarithm. when it is base and the exponent, and this anti-logarithm. Take it easy. Take time. Studying is very fun. It is not the former. If you are take it easy, the math will be solvable. Take your time to approach one by one. Each one every day, if you solve one questions, you still have much more time. So you can even raise your points by 20s or 30s in the SAT or college entrance exam. From now on, you have to solve the questions to each every day. Okay, what the properties of log? Okay, in this way. First one. 0 power of every number becomes 1. So, and here, what we have to know why. Why does it become this way? I'll explain it to you. Exponential form. 2 to third power divided by 2 to the third power. When in the exponential form, the base is the same, and since there is a division, so this is 2 to 3 minus 3 power. It becomes 2 to 0 power. 0 power of all the number. 2 to the third power divided by multiplied by. You can change into reciprocal form. 1 over 2 to the third power. Aha, it becomes, and then you have to reduce fraction. Now you can bring it in your mind. A to 0 power is, since A to 0 power is 1, 1 to 0 power is 1, 2, and 2 to 0 power is 1, 2. 1 over 100 to 0 power is 1, 2. All number 1. It is provided that A is not equal to 0. A to 0 power. Since 0 to 0 power is this one, we can meet it in the limits. 0 power of all the number is 1. Can we say that? Yes, it is. We change it into log relation. Since 0 is log base 1, 1. This is one of the properties of log. Okay, we write it again. Log base A to 1 equals 0. Think with the logarithm. You can write it this way. F of 1 becomes 0. Now, when you see this in questions, aha, this related to the logarithm. You have to get a hint. Out of this phrase, f of 1 equals 0. This is about logarithm. You have to get a hint. Okay, once more. All the log base A to 1 power is becomes 0. F of 1 is 0 is about logarithm. Why is it? Because there are so many kinds of log, like exponential log, logarithm, and rational or irrational logarithm. Since if you know the relation, which function does this questions related to, that's the time we can solve the questions. I've already told you that if you know the definition, you can solve it well. Okay, let's move on to another one. The number 0 and 1, I've told you so many times about that. It is very important, the number 0 and 1. a to the first power becomes a. You have to say it with the word. Long time ago, I told you. I said 0 doesn't exist. Number 1, it exists. Since it exists, it becomes number itself. Even you guys need to know about that number for sure or very clearly. Since 1 is log base a to a power, if the base and the anti-logarithm is the same, it becomes 1. Since let's change into f of a equals to 1. Aha. It is related to logarithm. Did you get a hint? Since f of a equals 1, it is all related to the logarithm. Okay, let's make some example. Let's say we change it to another way. Log to base a to a power is 1, and log to base 5 to 5 power is 1, and log base 1/2 to 1/2 power is 1. Since the base and the anti-logarithm is the same, it becomes 1. Using the properties of logarithm, we can approach 1 by 1. We already induced from the exponent. The fact that the logarithm is based on the exponent. You have to know the fact. Okay. Out of the logarithm, the third one, log base a to x power equals m. Now you have to substitute. You know what is substitution? Since the expression is complicated, you use the substitution. You know, base a to x power is m. Exponential, let's change it into exponential form. X equals a to m power. We have changed it again. Oh, did you see the equal signs here? Equal relation. Since it is equal, the size, left side and right side is the same. Isn't this all about math? It is very important part. Okay, let's say here, the left side, the exponent, we have to multiply the n. And here, right side, multiply by n power. Okay, once more, mn relation equals log base a x to n power. Since we substitute for m, we have to substitute again for m. Since leap out to front, n log base a to x power is log base a x to nth power. Aha. What is it? What does it mean by? Since the exponent of this anti-logarithm could be changed into, let's say, log to base 10 to 2 to third power. Since the 3 leap out to the front, 3 log base 10 to second power, it is the same. Out of this formula, using this formula, we have to change it into functional form. F of x to m power equals n f of x. Is this also properties? Yes. We have already learned 3 kinds of properties f of a equals 1. F of n to x power, x of n power equals and f of x. How many relation? Why don't we expand more? Expansion of thinking is the process of your studying. It is not important that you know a lot. One by one, you take it seriously, so that make out your thoughts as big as snowball. Not only with the math, but also other subject you can influence. Log to base a to x power equals a log base a to y equals n, with two kinds. Okay, let's think it over once more. X equals a to m power, an exponential form, a to y equals a to m power. Since there are two equations, could we multiply or divide? Xy equals a m plus nth power, since the base and the anti-logarithm is the same. Okay, m plus n relation, log to base a to xy. Okay, let's substitute. Go back to the original. Log base a to xy power equals log base a to x power plus, what is n? Log base a to y power. Oh, anti-logarithm, the multiplication of anti-logarithm becomes the addition. Okay, apply this to the functional form. F of xy equals f of x plus f of y. When you see this kind of formula or these equations, this is about logarithm. Now we have learned 4 kinds. Even the formulas are 4. If you don't study generally, it takes a lot of time. If you don't study horizontally, if you study vertically, there are too much formulas. You are so much complicated. Not only you guys, students, but also the teachers teach math very simply. So you just get very complicated. Okay, the 5th one, the properties of log. Log base a, x equals m, and log base a, y equals n. Change into x equals a to m power. Change into exponential form. Y equals a to n power. Previously we have learned we multiplied. Now this time we have to divide. X over y equals a to m minus nth power. Change into m minus n relation, log a x over y. So we substitute for m and n here. When we substitute, log base a x over y power equals log a base a x minus log a to y power. Since quotient is substitution, multiplication is addition, let's change it into logarithm. Out of this part, f of x over y equals f of x plus f over y. Since this is equal, there is equal sign, it is about the logarithm. We have induced the properties. Induce the properties and formulas, you have to prove the formulas. Just write the properties. The first one. Yes, right. F of 1 equals to 0. This is one of. The second one is f of a equals 1. And the third one is f of x to nth power becomes n f of x. And the fourth one is f of xy becomes f of x plus f of y. The multiplication becomes addition. Multiplication becomes addition. The fifth one is f of x over y becomes f of x plus f of y. The quotient is with the substitution. It is so easy to. It will be given in the questions. Can you analyze the questions? Can you make out the questions? Now you can solve it yourself. Since you study logarithm and the properties, and now you know how to make out or made of. Okay, these are the properties of logarithm. We have learned definitions and properties up to now, and then what can we study more? And the formulas. What can we do with formulas? We have to prove. The sixth one, the base transformation formula. Base, what do we do with the base? Transform. The formula, what do we do with the formula? We have to prove. Okay, let proof as PF.